Welcome back to another Algebra 2 lesson. It's Mr. Lambright here. We are going to do lesson 4.9, which is all about quadratic inequalities. Remember, inequalities, when we graph them, are the ones that have the shading on the graph. So we want to make sure that we get the shading in the right place, because now we're either shading inside of this parabolic curve or outside. And we'll learn more as we get started. So there are four types of quadratic inequalities. And we're going to use the rule based on the sign. The signs are always going to be what helps us know, one, whether it's dashed or solid, and two, whether it is shaded inside the graph or outside of the graph. And part of that is going to be using a test point. So one of the things these notes say in this paragraph is these two signs, as usual, are going to be dashed. So that would be 1 and 2. And then the less than or equal to and the greater than or equal to will be solid. So based on those signs, you'll know whether it's dashed or solid. So that's a good start. We will be using the test point method to determine whether we shade inside the parabola or outside of the parabola. And I think the easiest way to do this is to go on ahead and get started. So this problem says y is greater than x squared minus 2x minus 3. And for the purposes of this problem, we're going to assume that you are getting your points from table of values from your calculator. So I'm going to plug in x squared minus 2x minus 3 into my calculator. And it looks like this, the graph has a vertex of 1, negative 4, and then points at 2, 3, 4, going to negative 3, 0, 5, and then negative 1, negative 2, negative 3, also at negative 3, 0, 5. So we're going to plot those points. Right 1, down 4. And then we've got the negative 3s. Oh, shoot. Sorry, apologies. Definitely skipped something. I skipped 0. So that should have been 0, negative 1, negative 2. Look, we're teachers. We make mistakes too. Okay, so then we go negative 1, 0, and 3, 0. And then right 4, up 5. And then the next points are off the graph. And we will graph this in dashed because it is not an equal to problem. So that's the first part. Get the graph on there. Now, we do know that if we used our graphing calculator, we would be able to see whether it was shaded inside or not. But since the notes have the test point method, that's what we're going to do. Turns out that for this particular graph, 0, 0 is inside. So I'm going to plug in 0 for y, because y value is 0. I'm going to plug it in for x. And we're going to simplify this. If it makes a true statement, we shade inside where 0, 0 is. If it makes a false statement, we shade outside because it only works where 0, 0 is not. Again, this would work with any point inside the parabola. So 0 is greater than, that's going to be 0 minus 3, which is negative 3. 0 is greater than negative 3. So because 0, 0 worked, we shade where 0, 0 is. This one is shaded inside the graph. And that's it. That's all there is to it. Graph it. Decide, while you're graphing it, make sure you decide correctly whether it's dashed or solid. And then do a test point. And again, if you changed to the inequality symbol on your calculator, when you're graphing this, you would have actually gotten the shading as well. The shading would have been given to you. If you need help remembering where that is, please ask your teacher. Okay, so now we have a system of inequalities, which means we're going to be graphing more than one parabola on the same graph. For the purposes of this This one is going to be orange, and the other one I'm going to do is green, and then the shading will be a different color too. So for the first one, let's start. We'll do y is greater than or equal to x squared minus 4. This right here is what tells me that it's going to be solid. And then the other one is y is less than negative x squared minus x plus 2. And we're going to get a table of values for both. So you'll see I plugged those into my calculator. I got the values. And now we're going to plot the points. So for the orange parabola, we are going to go down 4, up to negative 3, then up to 0, and I believe values again from your graph would show that you would go up to 5 next. And we'll connect those solidly because it is a solid parabola. And then on this other one, I had to change my table settings to get the vertex, which is negative 0.5, 2.25. So just a little bit over 2. And that's not even quite in the right place. And that's not either. Whoops. Alright, and then there were points to be made. Give me just a second. Alright, and then we go down to 0. And then negative 4. And it'll keep going from there. This one is dashed because it is not a solid line. And so here's what I know. I know that I'm going to test 0, 0 on both of them because 0, 0 happens to be below the green one but above the orange one, and it's going to give us an idea of where we would shade. So 0 is greater than or equal to 0 squared minus 4, which will simplify to 0 is greater than or equal to negative 4, true. So it's going to be, because that's 0, 0, so it's above. We know we'll be shading inside the orange parabola. And we don't know yet, we don't know where both of them are shaded yet, because if we're shading outside the green one, we'll end up shading here. Basically saying, okay, we know we'll shade inside the orange one. And for the green one, test the same point. Is 0 less than 2? Yes. So 0, 0 is inside the green one, which means the only area that's going to get shaded by both of them is the one in between. It does not always work out like that. It just did now. And remember, once again, just like before, if you changed your signs in your graphing calculator, it would have shown you where the overlap was on the graphing calculator, and we wouldn't have to do a test point. Another way to solve quadratic inequalities, actually to solve them, to actually get an answer, is to graph it first. And that's where we're going to start. We're going to start by graphing. We do note that we're going to be dashed because it is not equal to. We're going to go to our calculator and get an XY chart. So I type in to my calculator x squared minus 6x plus 5. Looks like I had a little bit of a typo there. And it looks like we've got a vertex at 3, negative 4. And then we have, 4, 5, 6. And we will have points at negative 3, 0, 5 in the opposite directions. So we're gonna plot those points. Again, this will be dashed. So write 3 down 4, and then the negative 3, the 0, and 5. Dash, 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 dash. Dash, 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 dash. And the question that we have is, for what values is this graph less than a y value of 0? So y is 0 here, this line. And it's saying what x values is this graph under 0? So this is not a shading problem. It's saying really what x values is it between, and that is it is between it is less than 0 between 1 and 5. So x it's greater than 1 or less than 5. It is less than 0. And it has to be these symbols because it didn't have an equal to before. So it is less than 0 between 1 and 5. So we graphed it. We decided to see where it was below the x-axis. If it had been greater than, we'd be saying, where is it above the x-axis? But because it was below, it was from 1 to 5. This thing goes below the x-axis. We can also solve for that algebraically. So the first step it says is to replace the inequality sign with an equal sign. Then we are going to solve it, and we solve these by factoring, and I can't factor until everything is on the same side, so we're going to subtract 8 to the other side. If you don't remember anything about factoring, you can go back to the lesson 4.3, 4.4 video. So a times c is on top, a is 1. A goes in the sides, b goes down here. What multiplies to get negative 8, but adds up to 2, that would be 4 and negative 2. Looks like I've got, there we go, little typo. Not typo. When you're writing, it's just a mistake. So we get x plus 4, x minus 2, and this says solve for x. So this is the one where you have to do x plus 4 equals 0, x minus 2 equals 0, so x equals negative 4 and positive 2. Then it says, step 3, plot the values on a number line. So we're going to make a number line. From, I always go 1 out, negative 5, negative 4, because negative 4 is the lowest, so we made sure negative 4 was on there, and like I said, I always go 1 out. And that's going to be important for testing, actually. And then 2 is my higher value, and so I put 3 on there to test that area too. You'll understand what I mean by that here in a second. And so now I plot the values on the number line. I found negative 4. I found 2. And those are solid because of that equal sign. We already know to make them solid. Okay, so then we got 3 intervals. Everything under negative 4, everything between negative 4 and 2, and everything above 2. And we are going to test a number from each of those. So I'm going to test negative 5, 0, because it's just math is easier that way, and 3, and see if it's true. If it is true, then I'll have a spot on the number line like shaded in. But if it's not true, then we will not shade that part in. And so we're going to start these one at a time. We'll do negative 5 squared plus 2 times negative 5 is less than or equal to 8. That's going to give us 25 minus 10 less than or equal to 8. 25 minus 10 is 15, which is not less than or equal to 8. So this part is not getting shaded. The part to the left of negative 4 is not getting shaded because it did not work. Okay, we're going to do the same thing with 0 now. 0 squared plus 2 times 0 is less than or equal to 8. 0 is less than or equal to 8. That works. So we know we're going to shade in this area in between because a test point from in between worked. Now we just don't know if we're also going to shade to the right, which could happen. So we're going to test 3. And we're going to do 3 squared plus 2 times 3 is less than or equal to 8. 9 plus 6 is less than or equal to 8. 15 is less than or equal to 8. That is not true. So we will not shade that area. And we will only shade in between. It could happen that you shade the other ones. It could happen that you shade everywhere. But in this case, we only shaded in between because that was the only place that had a test point that worked. That is where we're going to leave things today. We're going to end there, and we will see you all again soon in our next video.